Alright, Chapter 5, Number 17. The distance between two telephone poles is 50 meters. When a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags zero point 0.2 meters. Draw a free body diagram of the bird, and how much tension does the bird produce in the wire? Ignore the weight of the wire.
Okay, so in this problem we have two telephone poles. That's pole number 1, and that's pole number 2. And there's a telephone wire that goes across them. And we're gonna have a little birdie, little snout there. He's gonna land. Gotta draw the bird legs. He's gonna land on the telephone pole. I don't know what that is. And then the telephone pole is gonna sag because I'm gonna exaggerate how much it sags. So the telephone pole is gonna sag. So instead of being straight, it's gonna sag because the bird's standing on it. And we know that the bird's mass is 1 kilogram. We know that he makes the telephone wire sag by 0.2 meters. Sorry, it could be a she. Androgynous bird. It's gonna make it sag by 0.2 meters. And we know that these two poles are 50 meters apart. So, we're going to draw our free body diagram on the bird, as is part A. So if we have our object, because I don't want to draw another bird, there are 3 forces acting upon this bird. Well, 2 are the same, but you have the weight going down, so the force of gravity, which is equal to mg, and you have the tension in both of the strings pulling the bird up and away. So, what we do know is mass and gravity. What we don't know is tension. But what we do know is because the bird lands in the middle of the 2 poles, we know that T1 is going to be equal to T2. Okay, so how are we going to go about solving this? Part B is sum the forces. So we're going to sum the forces in the y direction. So if we're going to call this down, this is positive, this is positive, and this is negative. We got our positive ones is going to be, I don't know if you can see this. Our positive going up is going to be T1 sine theta and T2 sine theta. And theta is the same because the wire, since he lands in the middle, the wires are sagged at exactly the same point. So this length here is T1 sine theta, this part here, this y component, and then the same goes for this T2 sine theta. And that's going to be minus the force of gravity, which is mg, and that's going to equal mass times the acceleration in the y direction. But this bird is staying still, so acceleration in the y direction is 0, and we can erase that and make it 0. And then that's all going to be in newtons. So how do we go about solving this? Well, we don't know T1, we don't know T2, but we do know T1 and T2 are the same thing, so I'm going to make this into T1. We know mass, we know gravity, and that's 0. All we need to do now is find the angle, and it tells us if we can draw this triangle down here. It tells us the wire sags by 0.2 meters, and we know that this distance is 25 meters because the bird is midway between the poles. So now it's just simple trigonometry. Tangent theta equals 0.2 meters over 25 meters. And that gives us a theta value of 0.458. So as you can see, I exaggerated this angle a lot. So now that we have theta, now that we have mass and we have gravity, we can solve for T1. So 2T1 sine theta equals mass times gravity. T1 tension equals mass times gravity over 2 sine theta. We plug in our values, so T1 equals, our mass is 1 kilogram, gravity is 9.8 meters per second squared, and we don't need to make that negative because we already did right here, and 2 sine of 0.458 degrees, and that's going to give us a value of 612.5 newtons. And we already said T1 is the same thing as T2, so that's your T2. That's the tension in the string.